Cool.
Less than 2 days.
40. Perfect. All right, we're gonna jump right into it. Everybody, this is mostly for Ramsey, but you guys are welcome to chime in or what have you. Ramsey, I'm gonna go rapid fire because this is how the exam is gonna go.
Cool.
Okay. All right. Claude's probably gonna throw some stuff at you too. So just quick tips, keep it simple. Just like last night that we shared with you. The exam is gonna be if the exam throws bones at you and you throw bones back, then both of y'all just gonna be throwing bones at each other and lost. And it's gonna be 60 minutes and the exam's gonna be over. Okay?
Yep.
All right. With that being said, what's a router? What does it do?
Yeah, it forwards or blocks traffic in between networks.
But
What layer does the router operate at?
Layer 3.
cool. Layer 2 switch.
Yeah, so a layer 2 switch is going to filter, forward, or flood traffic, unicast, broadcast, or multicast traffic. If let's see what else. If it's broadcast, it's going to go out all ports except for the port it came in at. It's going to save the source MAC address information from traffic and put it into its MAC table or CAM, we call
it. Okay, perfect. Okay, so now we're talking about L2 switches. Let's go ahead and take a detour before we jump to L3. What are the 3 basic functions of a switch?
Say again?
The 3 basic functions of a switch?
Forward, filter, or flood.
Explain.
So if it gets a unicast packet, it's going to forward it. If it's a broadcast, it'll forward it out all ports except for the one. Filter would be, it's not going to send it out the port it came from, so it's going to filter that. And then flood, rather, would be broadcast. It'll send it out everything except for where it came in at.
So it's just going to pass traffic and learn MAC addresses. Is that what you're saying?
Yes, that is correct. It's going to pass traffic.
That is the only functions of the layer 2 switch. You want to think about that for a second?
Well, there's some VLAN going on in there, but yeah, it's just passing traffic.
Okay, everybody write this down. 3 major functions of a switch. Ramsey hit on both of them. There's one last one, which is meant to prevent loops on redundant links utilizing spanning tree.
STP.
Okay. All right, let's keep rolling. Layer 3 switches.
Allow for inter-VLAN processing, and
keep it simple. Keep it simple. Keep it simple. Layer 3 switches. What do we do at layer 3?
Yeah, IP. So it's going to use the IP information for ARP.
Okay, so let's go back to the definition of router, right? Keep it simple. A router is just a device that routes packets from one network to another, right?
Yep.
What are we going to do with L3 switches?
We're just going to pass traffic through its ports. Depending on
from one network to another, right?
Yes.
Perfect. Simple enough. Okay. Claude, I'll let you jump in.
Okay, so on layer 2 and layer 3 switches, we use the term MAC address table loosely. What is the MAC address table also known as?
CAM.
And what is that short for?
I don't remember.
Content addressable. What's the last one? Content addressable.
Media.
Yep, memory table. Yep. Content addressable memory table.
Memory table.
Yep. Claude, you're right.
Let me. Yeah. I was just slowly talking to see if he was gonna spark a memory in him. Okay. Let me ask you this. Can you connect an endpoint, or I should say an end user, to a routed port on a layer 3 switch?
So routed port would be layer 3. It's a good question. Yes.
You can connect it, but will it operate?
Yes.
Okay, that's going to be a no.
Okay.
So remember, if you're connecting end users, PCs, laptops, things like that, always think access ports.
Right.
Okay, access.
Okay. And a layer 3 turns it to trunk. I know.
When you go layer 3, you now make it a routed port. You're now capable of routing traffic to other devices, or even out to the World Wide Web at that point. So in essence, it becomes a router. Okay. Let me ask you this. Layer 2 and layer 3 switches have what's known as templates that they operate on. Are you familiar with those?
Templates?
Yes.
No, I'm not sure. Tables?
No,
These
templates.
are, yeah.
So let me give you a hint here. I know Claude is throwing a doozy, but it's in the book. So template, meaning, how do you want to set up the memory allocation for your different processes or things that use like VLANs or MAC address tables or what have you, right? So you're going to have, and Claude, correct me if I'm wrong, you're going to have, a template for if you're just going to do some layer 3 functionality, or if you're just going to have a layer 3 switch, or you could have a template if you're just going to be doing switching, right? Claude, correct me if I'm wrong.
Correct. You on it. You on it.
And what that's called is an SDM template. Okay.
SD, Sam David.
Yep.
Yes.
Sam David Mary. So SDM template. Software defined memory template, Claude?
Mm-hmm.
Okay, cool.
No.
Okay. And what you do is, if you're unfamiliar with that, pull that out in your book. All right. Take a look at those templates, and you'll see that each template, okay, there's 3 different main templates that switches actually run, and your packet tracer probably will show you the exact same thing. And like you said, just like in your Windows PC or your Mac PC, there are settings and parameters for a particular type of performance. Okay.
Oh.
And
all right. So yeah, I think so. So this dictates how it perceives traffic, like how much of the MAC address it reads, or if there's error detection.
Well, what it'll do is, as far as memory, it will allocate a certain portion of memory for, like David mentioned earlier, it'll allocate a certain portion for routing purposes. They'll allocate a certain portion for IPv version 4 MAC addresses, IPv version 6 MAC addresses, and things like that. Okay.
Yeah. Okay. Thank you for that. I've got it written down.
Mm-hmm.
Check it out.
All right. Let's go to the next one. Next generation firewalls and IPS. All right. So I didn't see too much of that in the CCNA book. So tell me what you know about intrusion protection.
Yeah, so IPS bases its behavior off of signatures. So it saves, let me think about it. The way I think about it is it's like a method. So if there's a bad website out there that's been, declared like source malware wouldn't be the right word, but yeah. So if it's a bad website, it's going to flag it, and it's going to disallow the user to go to it, I think.
Okay. So you hit it as far as IPS was concerned. IPS actually does something. It actually takes action.
Mm-hmm.
As opposed to its counterpart, was it IDS?
Yes,
detection?
IDS. Yep, detection.
IDS, right. IDS will just give you an alert. Hey, I got a bad actor coming through, but it will not take action against that. Okay. And I'm going to assume the CCA isn't going to go too much deeper after that. But understanding what IPS is all about, IPS is about it will detect and it will take action based on, like you say, the signature.
Yeah, they're in line is the phrase I see a lot.
Right. Okay, next one, access points. What is an access point?
It's a device that transmits radio frequencies so that clients can access the network. So they're wireless devices.
Okay. And what bands do they run at?
2.4 or 5 or 5.
Okay, perfect. So 2.4, within a production environment, let's say you have redundant APs throughout your network in a capacity design. What channels can you run at the same time and why?
Yeah, so it's in there somewhere. Yeah, you don't want to be trumping each other. And so 1, 6, and 11 is the perfect balance so that you don't have interference.
Good. Cool. Now, 5 gigahertz. Let's talk about that. What's the issue with 5 gigahertz and running it outdoors?
Right.
What does the CCNA tell us about that?
That it doesn't, it's a smaller wavelength, so it's more susceptible to being blocked, and it doesn't go as far, not as robust.
Wait a minute. Did you just say radio frequency is less susceptible of being blocked on 5 gigahertz?
Yeah, 5 is a smaller wavelength, and so yeah, so the transmission doesn't go as far or as strong.
Okay, you're correct, but I get what you were trying to say, so let me help you out, okay? So regarding not being blocked, you're talking about interference, right? So
yeah,
CCNA is not a wireless exam, so they're not going to go in depth. They're just touching on the basics. So 2.4, they have 802.11 devices like APs and whatnot, and they have non-802.11 devices like your microwave, like your IoT devices or what have you. And some other things, right? So that In 2.4, there's going to be interference. 5 gigahertz, there's not, because there's less devices like a microwave that's going to provide interference. Okay?
Yeah, I copy. Thank you. Yeah, it's not as crowded is the way they phrase it.
No. Yep, it's all good. It's all good. Claude, let's keep going. I'm away from the computer right now.
Okay. Let me see here. Tell me what you know about two-tier network topology architectures.
Yeah, so I love two-tier. So three-tier, you have core, distribution, and access. And so with two-tier, it's collapsed. And so you're basically putting together the core and the distribution together, because access is always going to just be connecting to the hosts. And that top tier is going to be layer 3 switches and a two-tier.
Okay. All right. So some of these characteristics of, let's go with the three-tier model.
Mm-hmm.
What are some of the characteristics that's going to be prevalent that you're going to see in the access layer in the three-tier model?
Oh, you mean like a port security, maybe?
You may see port security. What else?
That's the big one that comes to mind.
Okay. So you may see some port security. You may see port fast enabling.
Mm-hmm.
You heard of that term, port fast?
Certainly.
Okay. Port fast allowing the user to connect the PC up without having to go through the listening and learning of spanning tree. They come straight to it. Okay. One of the big things that can have a problem with a brand new PC trying to obtain a DHCP when they gotta bump into spanning tree is that PC can time out while it's trying to request an IP. Okay. Hey Dave, if you want, you can send that over to me if you want to let folks in. And what can happen is that while spanning tree is going through its phases, and you don't have port fast, and you plug a PC in, and it's searching for DHCP, it can actually time out, while spanning tree is doing this thing, and then before you know it, you're looking at that 169 input address. Okay.
That's a good point.
Let me ask you this. Which is easier to scale from data center to data center, the two-tier model or the three-tier model?
To scale up.
So if you're looking at two data centers on the East Coast, and you're looking at putting up a third data center, which would be easier to scale if you was in a two-tier model or if you was in a three-tier model?
I would think two-tier in a kind of a mesh situation would be ideal. Just you have less devices.
Two tiers, you're going to have would actually be a little bit messier to scale to, more sites. And the reason I say that is because you got more connections that you have to make for mesh. When you're dealing with a three-tier, it's just that one core that you need to connect with. Okay.
Yeah.
As opposed to not having that core. So that's what you got to think about. If you got the two-tier, you may have several different distributions that you got to make sure is connected to this brand new site for that redundancy.
Yeah, it's not
Okay.
funneled. Yeah.
Right. So like I said, the 3-tier, easier expansion. You got the one core that you got to connect with the other sites. And like I said, that's what makes it scalable in that fashion. Okay.
Thank you.
Soho.
Do we
What
want to do
does that
spine
term?
layers? Oh, sorry.
What is Soho? What's that term mean?
Yeah, small office, home office. So it'd be like my location here, or a little bit bigger, but it's primarily everything fits within a subnet is kind of how I think about it. The router might be something like I have here, where it's a router switch, and I'm just going directly to a ISP through that device.
Okay.
A lot of shared devices and that, like a printer and stuff like that.
Okay. Okay. Would you find possibly wireless technology in the Soho environment?
Yeah, certainly. Could be 2.4 or 5 and
Okay.
or 5.
Sure. Tell me the difference between on-premise and cloud.
Yeah, so on-premise would be privately owned. And obviously there's variations of on-premise, but yeah, and then cloud, you have the sections of private, public, community. And so private would be like a government agency that privately owns the whole infrastructure of the data center, from the security guards, the building, the electricity. They're paying for everything and all the upkeep. Public would be pay as you go kind of a scenario, where it's Amazon or Microsoft Azure, something like that. And so that would be the extreme. And then you have hybrids, where you might be pulling some software, but maybe you're doing a IaaS, infrastructure as a service for some stuff too. So the hybrid is kind of a mix of two of them. And then community would be what I always read was like banks, so a shared interest and also like shared security protocols that kind of define them, is what I think about as community.
Okay.
Perfect. Okay. Claude, let me go ahead and jump in.
All right, yeah.
Cool. Tell me PoE. What is it? Why is it used?
Yeah, PoE is used like for phones, IP over. It's anytime you want to send electricity and data over the line. So switches, some small switch, different items.
Wait a minute.
Power
Say
through
that
the
again.
cable. Power and data through the cable.
Line? Okay. All right, cool. Tell me about the difference between the different types of fiber, meaning single mode and multi-mode.
Yeah, so single mode is going to use a laser, and it can get much farther distance. The way I think about it is like single mode might be 2 miles or more, whereas multi-mode that uses LED light might be 2 miles or less. Multi-mode is two-way. I'm kind of stretching a little bit, but I think two-way, one is going each way, right?
Single mode is part of the distance, multi-mode is shorter distance.
Yep.
Picture it like this. Picture it like this. This is how I had to come to realize the difference between single and multi-mode. Pretty much everybody has one of those little mini mag lights, little flashlights. So if you turn that flashlight on up against a wall at 12 feet, okay, that light beam is kind of spread out across your wall, okay? Picture that as multi-mode. you pretty much got to walk up on that wall for that light to really be prevalent on that wall. You understand what I'm saying?
Mm-hmm.
Now, that's the shorter distance. That's where multi-mode comes in. Now, you go back to that same position on that flashlight and you turn that head until that concentrated beam focuses real small across that room. Now you got that concentrated beam on the wall. That's single mode. So you can transmit at a farther distance. Does that correlate mentally with you?
Yeah. And the width of the
beam.
Yeah, is thinner.
Yeah.
Mm-hmm.
So that's me personally when I think of single mode and multi-mode. I'm thinking of a flashlight up against a wall and how that beam looks when I turn that head. Is it wide? Is it kind of faded? Or do I turn it to the point where it's concentrated in one small point up against that wall?
Mm-hmm.
Okay.
Yeah.
Okay, let's see.
Cool.
Copper?
All right, all good? Need some water?
Nah, I left it downstairs. I'm gonna persevere. Thank you.
Okay. All right, no worries. Tell me the difference between TCP and UDP.
Yeah, so TCP, transmission control protocol. And so basically it's a three-way handshake to make it a connected session. And so it has a lot of functions because of that, like windowing and sequence numbers to kind of re-put things back in the right order. Whereas UDP is more for like video or situations where we want to have a low overhead and we just want to like pump that data. And it's okay if we're missing out on some of the bits. And so HTTP and HTTPS are TCP, whereas DHCP and a couple others are UDP.
Okay. Using your words, how would you configure Ether channel? A layer 2 one first and then a layer 3.
Ether channel?
How would you configure it? What are the commands?
Yeah, so I just need to think for a second. Ether channel. So there's two kinds of Ether channel. You got LL, let me think, LA, it's PGAP, LACP, and link aggregate. So the point of it is that you want to be able to aggregate multiple physical lines into one virtual line for redundancy and load balancing. And so for PGAP, we can show Ethernet, show Ether channel summary to see.
I don't want to confirm it. I want you to tell me how to configure it.
I have it on my notes right there. I'm forgetting.
It's okay.
I'd have to look at my
It's all
notes.
right.
Yeah.
It's okay. It's all right.
It's
all
the
right.
hardest part for me is, yeah.
It's all good. We'll walk through it. You ready?
Hit me.
Okay. Perfect. So Ether channel. Layer
yeah,
2,
start with the interface.
We're gonna choose 2 interfaces or 3 interfaces or however many interfaces we're gonna choose, right?
Yeah. One second, Claude. I think your mic is on, sir.
Yeah, Claude, we're getting feedback, buddy.
Sounds like you're underwater.
There
Thanks.
All right, perfect. So, Ether channels, right? So first thing we're gonna do if we're gonna want to configure it, right? We're gonna go ahead and we're gonna choose our interfaces. We're gonna go into we're gonna go from user exec mode to configuration mode. Okay, privilege exec mode. No, I'm sorry.
Global config.
Global config mode. Thank you.
Yep. And then it's interface fast Ethernet 02 through 05, something like that. So we're gonna identify the interfaces.
All right. So what's next? Keep rolling.
We're doing ether channel. We're going to turn it into a trunk.
We can. It doesn't
Yeah.
need to be.
Because I was thinking, if that was the case, that's where we would do
Remember what I
switch
asked you?
mode, switch
We're
port
just configuring the
mode.
ether channel.
Okay.
Nope. We're just configuring the ether channel. Look at your notes if you need to.
Okay. Yeah, if you don't mind, I'll be able to play along more. That's right.
All good.
Oh, where are we? Ether channel. Okay.
Right.
Yeah, so we're going to group them.
Good. Cool. All right. So what's that command?
Channel group 5 mode active.
Perfect. Cool. All right. So how do we verify that the ether channel is up and running? What command can we use?
Show ether summary.
Perfect. All right. Let's move forward. Tell me CDP, how to configure it, and how would you verify, and tell me about LLDP, how you configure and how you verify.
Okay, so CDP is to discover other devices. And so it's to simply enable CDP run. And then LLDP is the other one, not run, it's let's see it here. Run. Oh, I'm sorry, CDP enable, and then LLDP is run. So I try to differentiate those and really get them stuck in my head. The interesting thing that I find on the practice test for CDP and LLDP is which one is active passive and which one is desirable auto.
Oh, back that up. You talking about CDP and LDP, Link Layer Discovery Protocol? What
I
you
might have
should be
jumped
thinking
ship.
of, what you should be thinking of, which one is Cisco proprietary and which one is open source.
Yeah, that's right.
Okay. So if I got a Cisco switch, Catalyst switch, and a Dell 5360, would I be using CDP in that situation or Link Layer Discovery Protocol in that situation to see each other?
Yeah, LLDP.
Okay, there you go. We back on track. All right, Dave.
Yeah, and it's active passive for that.
For which mode?
LLDP is the cooler one, whereas the Cisco is desirable auto.
You going back to ether channel.
Isn't that what we're talking about?
Nope. We're talking about layer 2 protocols, LLDP and CDP.
Oh, you are. Yep. Sorry. They're right next to each other.
All good.
So I was kind of, but yeah, like if we could take a second and just kind of tease those out. So yeah, obviously like one's discovering the devices that are directly connected to it, CDP, LLDP. And then, yeah, ether channel is grouping lines together to make a logical single line. So yeah, I just had to get it out of my head. Thanks.
Oh, it's all good. It's all good, brother. All right, cool. Well, since we're on layer 2, let's go ahead and 2.5, a spanning tree. Perfect. Let's talk about spanning tree. Tell me about the different port states and roles in our PBST.
Okay, so for spanning tree, yeah, you have I'm just making a couple of real quick notes to get it straight in my head.
Take your time.
Root port, designated port, and then block, and then the BPD. in the Army, we wear BDUs. And so BPDUs happen to kind of be like an association that I can kind of play with. Okay. And then, yeah, the states you have, and I was mixing it up last night with Ospf, so that's why I'm taking a second. So
All good. All good.
BPDUs, you got,
Yeah, if you're going to use mnemonics, you definitely got to have that nailed. You got to have that hammered out, because everybody may use a different mnemonic for the same thing. You know, whatever you find that triggers you, you stick with that.
yeah.
Okay, but you got to work that out though.
Right. Yeah. Do the heavy lifting. Yeah.
Yeah.
So I'm just having a so for STP, having a little bit of deja vu of like last night. I'm like, why am I having a hard time with Stone Temple pilots?
Take your time.
So I got the ports, I got the mechanism, and the so they're all okay. Yeah, I don't know why I was just tripping on forwarding, learning, blocking. Okay, I think I'm ready to explain STP.
Perfect. Okay. So, so initially we have 3 switches connected to each other. What is happening? What is the switches first doing in regards to spanning tree?
Yeah, so they're each considering themselves as the root bridge when they're
Let's keep
turned
going.
on.
Perfect.
And let's see. So that's the kind of default setup. And then what I'm teasing out in my brain is they need to receive the BPDUs to get into the initial state, or am I mixing that up with OSPF again?
OSPF again.
Yeah. Okay. So so we have the BPDUs, and they're going to be sending those out. I'm sorry.
No, go ahead.
Yeah, so they're going to be sending them out, and they're going to be receiving them, and so they're going to see if they're superior or inferior based off of priority, loop back, address. They all want to be the highest, or IP address. They want to be the highest. And there's a caveat that it's going to look at its addresses to figure out which one it's going to use as its trump card. No?
Ramsey, OSPF.
Yeah. Damn it. I'm sorry. Okay. Taking it back. So we have the BPDUs, and they're going to see if they're the root bridge.
How are they going to elect who's the root bridge?
Yeah, so they're going to elect the root bridge by dispersing BPDUs, and if they get one that is bigger than that, more superior than them, they're going to change the information in their BPDU to acknowledge the other as a root.
Okay, let me help you out here, okay?
Thank you.
BPDU, or the switch that's superior, right, is going to be the switch with the lowest bridge ID. Okay, let me go ahead and help you keep it simple. Layer
Can you say
2
that one more
is
time?
going with,
It's the lowest?
say it again.
It's
Yeah,
the lowest.
so I'm gonna help you out here. Okay, so for election processes at layer 2, we're gonna go with the lowest value is the highest. Okay.
Okay.
Here's what I mean by that. I know that statement probably confused people. So if we have, for a spanning tree, if we have a bridge ID consists of priority and MAC address. Can't change the MAC addresses, but if we have a priority of 4096,
Right.
and we have another switch that has a bridge ID or a priority of 726, who's going to win that election?
The 4096, which is not the default. Yeah. Yeah. You got me back in the game.
Excellent.
Yeah.
All good. All good.
Yeah.
Keep
BID.
rolling.
Okay. Okay. Yeah. So the PPDUs go around. From that, they're going to decide who is the root bridge. Once that's decided, then the root port and the designated port and the blocking ports will be like manifested. So on the root bridge, its ports are all going to be designated and open.
Yeah. Okay. So that's the port state. What's the port? I'm sorry, that's the port role. What's the port state?
Forwarding.
Cool. Let's keep rolling.
Yep. And so on this switch, it's designated, and then alternatively on those links, it's going to be root port because those are going to be prioritized as having to forward. And then as you get further out in the topology, what we're looking for is loops. And so once it sees that there's a triangle, then it's going to go ahead and block one of the interfaces.
Keep going.
And so it's going to do them depending on which version of, no, that doesn't really matter. I was going to say which version matters. Like they're all going to look at the interface speed to decide the best path to the root bridge.
So not necessarily interface speed, but what's more prevalent?
Bandwidth.
What's more important than speed? Speed is part of his calculation, but what is it really looking for?
Bandwidth?
Not the bandwidth. You're looking at cost.
You're getting close. Yep. Talking about cost.
Yeah. Okay.
I'm surprised you didn't say that, speaking how you like to intertwine OSPF with spanning tree.
I think that's why there's certain kind of words that get crossed over, and then I end up crossed.
OSPF is cost heavy as well.
Mm-hmm. But the good part is it makes sense. Like I get, and I think that I'll be able to figure out which is which. But I think this is always a really good exercise, is to figure out which one is going to get blocked. So thank you for setting this up.
No worries. Who will be the root?
Looking at the MAC address, assuming all of them are 32768 or the default priority, I'm going to go with MAC address A at switch 1.
Why?
Because it's the lowest. BID.
What do you mean? The lowest?
It's the lowest bridge ID because you you have the priority number, and then you have the MAC address, and you combine them, and whoever's the lowest is elected the root bridge.
So switch 1's MAC address is higher than switch 3's MAC address?
Lower.
It's lower?
Yeah.
Perfect. That's what I was looking for. All right. Now what are we doing next?
Now we're going to set its ports to designated and forwarding.
Why?
Because these ports are priority and they have to stay open in order to empower the root bridge.
Okay. What about the other switches? What are we doing with those?
Okay, great. So, all right, I'm looking at the interface speed. They're all the same. So switch 2 gigabit 00 is going to be a port, a root port, because it has to forward and it's pointing to the root.
So hold on, wait a minute. So just because it's connected to the root, that's the reason why we're choosing it as a root port?
I thought.
Remember the nugget that Claude just gave you, cost. We're not basing it off connection, we're basing it off cost. So that's a gig link, right?
Yes.
What's the cost of a gig link?
4.
There we go. Okay, so.
And that's because of the training with you guys, by the way.
No worries.
Yeah.
So this has a cost. This has a cost of 4, right?
Yes.
Cool. So, and this has a cost of 4, right?
Yes.
Perfect. And this has a cost of 4, right?
Yes.
Okay. So you got 2 ports to choose from, right? For your redundant topology. Why can't we choose this link?
Let's see. So are we talking about the link between switch 2 and switch 3?
Yep. To make it a
Okay.
port. In comparison to the link from switch 2 to switch 1.
Right. Trying to remember. I know we went over it. So it's going to look at cost, and they cost the same. I thought that that next step to determine it would be the interface number, but they're the same.
What do you see there?
Yeah, so the cost, and then the bottom one, 02 to switch 3. Right. So 8.
Does that make sense?
No, sorry.
Okay. Nope. No worries. So
Yeah, just
all right.
simple
So
evidence.
if we take this way, right?
Yes.
And this link, it has a cost of 4, right?
Yes.
Perfect. Okay. So go ahead. But if we take this link, right? Cost of 4, but now we have to go through switch 3. That's another cost of 4.
Correct.
Which one is lower?
Green.
The lowest cost of the root. So with that being said, that's going to be your root port.
I follow you. That
Make sense?
yeah, the math has to equal. Now, so just to kind of circle the wagons on it. So for this left switch 2 to switch 1, if it was all right. I was just assuming because it's designated forward at the root switch that it has to be open at the other end, but you're saying that's not the case at all. And so I can see that now. That makes sense. So thank you.
No, all good, all good.
Yep.
So let's finish this and then we're going to move on to the next topic. I don't want to spend too much time on this.
Yeah, certainly.
Okay, so on switch 2, what will be the port states and roles on that one?
Yeah, so
0/0.
yeah, gigabit 00 is going to be forwarding, and it's going to be a root port.
Okay.
And then switch 3, it's gigabit 01 will be the same.
Okay.
And
what's
then,
left we have to do?
yeah, so this bottom wire, we're going to have designated on the left side for switch 2 because its MAC address is lower. And we would block switch 3's gigabit 02.
Okay, you're right, but clean that up. So what's the first deciding factor whenever these two that are connected to each other are trying to figure out who on this link is going to be forwarding and who's going to be blocking?
Yeah, so cost would be the determining factor.
Okay, which cost?
Cost to get to the root bridge.
There we go. There we go. Okay, so from switch 2's perspective, what's the cost to get to the root?
4.
Cool. Switch 3's perspective, what's the cost of getting to the root?
Equally 4.
Perfect. All right, so we need a tiebreaker, so we can't utilize the cost. So now we're going to use the bridge ID, right? Who has the lowest bridge ID?
Yep. And so switch 2 wins that.
There we go. And what are we doing with switch 3's link?
We're going to block it.
There we go.
Yep. So it's a backup.
And we're blocking on this one, right?
Mm-hmm.
Perfect. Cool. All right. Spanning tree's done. All right. All right. Ramsey, take a 5-minute breather.
Cool.
Anybody got any questions while Ramsey's taking a breather? Everybody all good?
Yeah, we
All
here.
good?
Yeah, I just want to
up,
say,
man?
I want to say, Ramsey, you doing good. Just know you up next, but it's quite a few of us who are coming up in the next month or two. So this will be us soon. So you doing a great job. Like, yeah, we here.
Absolutely.
So, good job.
That's the mirror back there.
Yes.
Yeah, what up,
What's
man?
up, man?
What's going on?
Yeah, that's the name of the game, is put yourself out there and learn and help each other. And we're all going to explain stuff differently, but as long as we can, hit the hammer on the nail, then we get to move on. And that's the goal. So thank you all.
Yeah, thank you. That's true. Because some stuff you named, I'm not familiar with. I'm like, oh man, I got a lot to learn. So I'm enjoying.
Yeah, I think I get caught up with all the other stuff. So this one is why it's so like in the back of my mind. But David is just always like hammering STP. So I've, which is good. So.
Yes.
Yeah, it's definitely a dope refresher.
But yeah, having this objectives, like even printed out, has been really helpful. I think I wrote like 55 pages of explanation to answer all these questions. And then once I did it, I was like, let me just write down like the quick and simple as fast as I can for each one. Just, it's always like just practice explaining. But the more concise, the easier it is for me to, relate to it.
But you're doing good. Just one quick tidbit I'm going to tell you,
Mm-hmm.
and I'm going to keep trying to drill it in your brain. Keep it simple, okay? If you get lost in the weeds, you're going to be standing on a question for 20 minutes. Then the exam's going to be over, and you're only going to be on question 5 or 6. Keep it simple. Yeah. Only answer what the question is asking. Yeah.
Mm-hmm. Copy that.
Don't let your thoughts outrun you. Do not let your thoughts outrun you.
Yeah, well, and that's why I wrote like a 1 sentence about each thing. It's just a bullet point. It's like, this is this. Kind of your North Star is what they call it in screenwriting.
That's it. Cool. All right. So with that being said, let's go ahead and keep rolling. I'm going to go ahead and switch it to Claude, and he's about to have fun with IP connectivity.
And I'm happy just to rapid fire through these. I could just say one thing about each if that helps.
Well, this what we're going to do first, because you have been so enthusiastic about OSPF. So here's your opportunity. So you explained earlier about TCP and UDP, right?
Yes.
And so let's start off with this. OSPF version 2. Mm-hmm. Are we using TCP or are we using UDP?
It's a good question. I never thought about it in terms of that specifically.
Come on, you had every other answer for OSPF now. Come on.
I know. So interestingly, like some of the internal protocols, it kind of goes back and forth. Let me think. So well, I would say TCP.
You say TCP? Why is that?
Because we want to make sure that it's the correct information. Kind of like if we're on HTTP and we're like going to our website or our bank, we want it to be there.
Okay. So here's the true fact about OSPF. Mm-hmm. OSPF does not rely on TCP or UDP.
Yeah.
OSPF operates on protocol 89. Okay.
Oh.
So OSPF actually rides on top of IP. Okay. So let me ask you this. In OSPF, we have neighbors and we have adjacencies. Can you tell me the difference between the two?
I would think adjacencies are directly connected, whereas neighbors, I might have them backwards. One's going to be directly connected, and one we're going to learn through the process of learning about. Yeah, so I think adjacencies are directly connected.
Okay, let me clean this up for you. In OSPF, a neighbor is nothing more than defined as two routers that are sending hellos to each other. That's all they are.
Yeah.
Okay. An adjacency, there has been an exchange of LSAs. There's been an exchange of routes. There's been an exchange of the topology.
Okay.
That's the difference. A neighbor just saying hello to each other. An adjacency is a little bit more intimate with the details of what the other one knows about. Okay.
Copy.
Keep that in mind. Keep that in mind.
Yeah.
OSPF. Explain to me the network types used in OSPF.
I'm trying to think of well, there's the stages that it goes through.
No, we're not talking about stages.
Right. So types, is what you said?
The network types.
Like types of neighbors or something?
No. So when we're talking about OSPF broadcast types, we're talking about network types. We're talking about broadcast, okay, which is the network type, which basically means you got OSPF routers on a segment that are within the same network. Okay. You have OSPF point-to-point.
Right.
That's a network type. All right.
Oh, I got you.
Is this starting to ring a bell now?
It does. Yeah. Well, designated routers and BDR.
Well, in the broadcast, in the broadcast where you have multiple routers, you will see designated routers and backup designated routers.
Yeah, but not in point-to-point.
In a point-to-point, where you see designated routers in the broadcast and not in the backup designated router?
No, because it's just two of them.
Right. And then you have what's your third one? What's your other network type?
Would that be starts with a D, dynamic?
No.
No.
So you got your point-to-point, then you have your point to
multi-point.
Exactly.
Okay. Yeah, point to multi-point, and that was what kept coming up for that was the DMVPN. But that might just be a part of it.
Right. That's basically a topology. That point to multi-point is a topology, which can be shared in DMVPN. That is correct. Okay, so let me ask you this. In order to have two routers reach the full state of an adjacency and actually become OSPF neighbors, what has to be present? What has to be present for that to happen?
An elected designated router?
Not necessarily.
Oh.
A designated router will be selected, yeah. But in order for two OSPF routers to become neighbors, what do they have to have present? There's some things that have to be matched on both sides.
Oh, sure. Yeah, there's the dead time and the hello timer and the dead timer. And the dead timer is usually 4 times.
Yep. Mm-hmm. What else?
Right. So the timers, and then they have to be in the same area.
Okay. What else?
There has to be a backbone.
Not necessarily. Not necessarily.
Right. It could all just be a single area.
Yeah. But there are little small things like you were naming that have to be in place in order for that neighborship to come up. Okay, let me lead you like this. You were talking earlier in reference to the states in which OSPF goes through. There's 5 of them. Okay. Yes. There's one thing that needs to be in place, and if it's out of order, the router will be stuck in X start. In the X start state. What is that?
Say it one more time.
So when the routers go through the initialization, the two-way, blah, 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 blah.
Yes.
Okay. This one piece of information on the 2 routers has to match on both sides. If not, it will get stuck in the X start state.
Right. Kind of tapping the tip of my tongue, but I don't remember.
Okay, that's NTU. NTUs have to match on both sides.
NTUs.
Or if not, they'll never reach its full state where everything's exchanged. The database is exchanged.
MTU, the maximum transfer unit.
Yep. Yep.
Okay, I caught it. Mm-hmm.
All right.
So that's default 1500, but it can vary.
It can vary, but if it varies, it has to vary on both ends of that segment.
Synced.
It has to be the same. That makes sense?
It does. Yeah. So the timer, the area, and the MTUs.
Yeah, and there's one more thing. There's one more thing that has to match. I don't know if you covered it or not, but it's authentication.
Sure.
Okay. In the real world, most routers that you're going to come across are going to have some type of authentication, MD5 or either SHA. So routers will not become OSPF neighbors if authentication is jacked up.
Now, in the real world, is that, just to deviate a little bit, is that centrally managed, or how does that authentication happen? Like, they can't all have the same password, right?
Yeah, they can. Yeah.
Okay. Internally.
Yeah, they can have the same password. Yeah.
And that would be a way to deal with the authentication without central management.
Right.
Mm-hmm. Okay. Admin.
Okay, so let me ask you this. You were talking about this before. What are the router ID rules?
Yeah, router ID rules. Yeah, kind of pivot my brain. So it's the highest. So it's yeah. So you have you can install. You can put in your own. You can configure your own router ID, and whichever is lowest wins. Kind of double checking on that.
If you manually configure a router ID, that supersedes everything else.
Yeah. Okay.
Okay.
But then it's the highest. But if there was like 4 routers, then 444, 4444 would be 1111, right? It's the highest.
No, a router ID is only going to affect that router locally.
I'm tracking now. Yeah, because the router has to look at all its interfaces to decide which interface it's going to delegate as its like representative number, right?
The highest interface on the router, yeah, that could be a criteria for the router ID. That could be, yes.
Mm-hmm. Yeah. So the router ID is the router. I'm sorry, the router ID rules are: number 1 would be router ID. Loopback would be its second choice, and then third would be its highest IP address.
Right. Okay. Let me see. Can you tell me the first 3 LSA types?
LSA types, link state, advertisements. So you have initialize. Number 3 is two-way.
No, you're thinking about you're thinking about OSPF states when it's coming online.
Oh, link state advertisements. Well, I know that there's LSUs, there's updates. Is it like the ARP table?
Mm-mm.
No.
This is how OSPF routers communicate and draw the topology with each other.
Right.
They create a link state database.
Yes.
Okay. And what happens is within the area, there's what's known as the router LSA. LSA number 1. Okay.
Mm-hmm.
Then you have LSA 2, number 2, where they're talking about the networks within that area. Okay.
Okay.
And then you have your LSA 3.
Hey, Claude, I got an A for you. I got an A for you. Ramsey, look at my screen.
I'm looking. Thank you for doing all this.
Nope, you're good. I wanted to use Wireshark to do a capture, so you can put, I know you like details. So Claude, go over LSAs again, and I'm just going to click through them, and so we can explain it to them.
LSA 1.
So type 1 is your router LSA.
Yes.
Okay. And that's basically going to tell you the identification. That's going to identify the routers within that given area. Okay.
Mm-hmm.
Then you have a type 2 LSA, all right, which is your network. And what you're going to be looking at there is the networks that's within that given area. Okay.
Mm-hmm.
And then you have, if you have a situation where you have 2 areas, you got a backbone in another area,
Mm-hmm.
you're going to have an ABR in between them. Okay. And that ABR is what's going to be sharing the information from one area to the next.
Yes.
And that's going to be
One interface.
That's going to be a type 3. Right. That's going to be your type 3. That's going to be your network summary. So that LSA, that type 3 LSA is going to be basically saying, okay, this network that you guys don't know about is over here. Okay. And like I said, that's how the LSAs, type 1, type 2, and type 3 go.
Ah, okay.
Right? Now, there's many more, but if you get the first 3, or even if you just focus on the first 5 on your own time, that's good. But I think the first 3 is probably what you need to hone in on, being on Because I'm thinking the CCA isn't going to do multi-area. OSPF is going to do single area. So if you
just
focus on
single area.
just single area. Okay, so if you focus on type 1 through 3, you should be well more than good.
And those are the different types of router roles, are the types?
No,
Like you said,
that's basically talking about the networks inside of. Matter of fact, let me go to my CLI real quick. Hold on a second. Let's see what I got here. Oh, wait a minute. You got those powered on, Dave? Oh man. Okay, yeah. Go ahead and
I'll do it in the background for y'all. Yeah.
Yeah. Can I take control, or can you send me control of that?
Yeah, go ahead.
Okay. Here.
Claude, it says I can't give you control. You run in Windows 7.
XP.
All right, go ahead, dog. You got it.
All right. Let me do this up here.
Yeah, thanks. Because this is new for me, so it's great that we're taking a little time on it.
Yeah, OSPF definitely is going to be talking about some LSAs for sure. So here, what you want to think about is show. You talk about me and Windows 7. Hold on. Okay, there we go. Show IP OSPF database. All right, so here's your LSAs right here. All right, you got your type 1 right here, which talks about the actual routers within that given area. So see here, what he did, he set up a single area 0, aka the backbone. Okay, so here we got router 1111 and router 2222. Okay, that's your type 1 LSA. And if you look at this one here, what did I tell you the second LSA type was? You got it written in your notes?
I didn't get that one. I only got the third one, ABR.
Okay, that was your network. That was your network LSA type. Okay, LSA 2. All right, and what you got there, that's the network that's being used in that given area. So here we're looking at 10.10.10.2. Okay. And what I'll do is,
now they're both in the area. Is one an ABR, or how are they different?
so here's the thing. Here's your network, right? That's on this interface, gig 00 on R2. Okay. Now here's the thing. You're talking about how are they different? So let's do this. We want to see if we got a neighbor, an adjacency established. All right.
Yeah.
So here we can see that router 111, which is basically router 2, all right, is what?
The backup designated router.
Exactly. So we're going to go over here to router number 1, and what we're going to do is we're going to see its perspective as far as the adjacency. And what do we see here?
Yeah. That router 2 is the designated router.
Router number 1. Number 1, which has probably a loop back on there, 2T22. Okay? All right. Now, let me ask you this. How is the designated router selected?
Through the link state advertisements? So I can hear
Give you a
myself.
hint. Give you a hint. There's something in reference to priority. Okay.
Mhm.
You ever heard
Whoever
about
has
that? Whoever has what?
yeah, the router ID, for example.
OSPF. Let me see this command. Let me see if this command works here. Let's see. All right, here we go.
Mm-hmm. It's familiar.
So when you're thinking about who's going to be designated router, you want to think about priority.
Mm-hmm.
All right. Priorities can be selected from 0 up to 255.
Mm-hmm.
The router with the highest priority wins the designated router selection. Okay. You may have seen some of this conversation that I may have had with Ala on the forums chat, where we were talking about designated routers and backup designated routers. And I was explaining to her that the backup designated router was actually selected first in the background because you want to have the backup in place first, just in case there's a process selection problem with the designated router, and the backup has to be ready to step in place while all that's getting sorted out with the designated router. Okay. Earlier, and I can't stress this enough, especially for the CCNA, because I cannot think. I know my CCNA was hands-on heavy when I took it back in the days. But your show commands, are you familiar with this here show command?
Yes.
Show IP interface and whatever the interface number is?
Mm-hmm.
Okay. Here, you're going to have to be able to glean certain information based on the questions I've asked them.
Mm-hmm.
Okay. So I was talking about earlier network types, and I went through the whole process of what types of networks, OSPF type networks here. Here you can see this is a broadcast. Okay. So you can also see your priority here. All right. You can see your designated, it's a designated router status. Okay.
And how
You can see your router. You can see your router ID here. Okay. You can see your hello timers here. So if you ever find yourself in a situation where you are literally having problems with an adjacency coming up, you got to be able to know which show commands to look at to get the information that you're trying to get. Because if you're looking at your neighbor here and you have a timer set for 1040, hello dead, and you come over to its neighbor that it should be connected with, and let me see, show IP OSPF interface. What was that? That's tiny. Gig 00, GI0/0. All right. Now this one here is good because they're actually adjacent to one another. But let's just say you ran the same command on the neighbor, and the network type up here says something like network type point to multi-point instead of it saying broadcast. Okay. You're going to have a different set of timers here. Okay, which is going to be a problem. Follow me?
I do.
Now,
Yeah.
here's the thing. This won't be expected at your CCNA, but I'm about to give you a troubleshooting gem. You can have different broadcast types, different. Let me back that up. You can have different network types within the OSPF topology, even as far as neighbors are concerned. But you're going to have to match those timers up, which means you may have to do a manual adjustment. Okay. So when I was talking about the thing where you had two routers that you know should be neighbors, but you got some kind of problem in between keeping that from happening, okay, make sure your neighbors is your timers are right. one of the questions I asked you earlier was what are some of the things that have to happen, has to be correct on both sides in order to have that neighborship? Think about that right there. Okay. OSPF is a very complex protocol. Very. CCNA is just touching the surface. I mean, you can get lost for hours within OSPF. Okay. But like I said, link state advertisements, you're going to find them that they're going to share the same.
What was the first type?
Broadcast, the network type, broadcast.
Oh, okay, yeah.
Hey, Claude,
Thank you.
coming up on 9:45. We're going to close out
Okay.
a little bit.
All right.
And we'll do a part 3 tomorrow and focus on the other topics.
Okay.
Thank you.
Now you can keep rolling with your breakdown, Claude, and this will be the last topic.
Okay. Yeah, so you see here, these are the link state advertisements for both these routers. And actually all the routers within an area will show the same thing. Okay. The thing about OSPF link state, as opposed to something distant vector or something like that, link state, everybody knows about everybody draws a full picture of the topology. Where vector, distant vector only knows about the next hop. Okay. So R1 knows about what R2 knows and knows what's on the other side of R2 if there was another area attached to there. That's what makes OSPF so unique. It knows stuff behind the walls. Okay? Because like I said earlier, the stuff that happens in OSPF, let me ask you this. We were talking about cost, all right? What is that algorithm that OSPF use to determine best path, shortest path? You remember it?
I think so. So, well, every dynamic routing protocol, every protocol has an administrative distance. And then you're asking about the cost for OSPF. And it's like 100,000 divided by 1,000,000, I think, something like that, okay, to come up with it.
What you're talking about is the AD. You're talking about the AD. So if you want to talk AD, what is that? What is that simple number right there?
What am I looking at? Sorry, the backup?
Yeah, if you look into a routing table, OSPF is going to have an administrative distance of a specific number. You know what that is off the top of your head?
The AD for OSPF, 110.
Yeah. Okay, good deal, good deal, good deal.
Yeah,
and listen here, the algorithm that OSPF uses to determine its best path, its shortest path, is called Dijkstra. You ever heard of that?
Oh, yeah.
Okay, the Dijkstra algorithm, remember that.
Yeah.
All right.
ISIS uses it too.
Mm-hmm. All right, and on that note, David, we can go ahead and call it right here.
Cool. Guys, any questions? All good?
No, actually, I have a question here. So Claude, you said that it's called the Dicer algorithm. Is that what you said?
Dijkstra.
Oh, okay. Could you go into a little bit more detail with that? I do remember reading it, but I don't really have too much experience with that.
So basically, picture you having to take a bus trip on Greyhound from Pennsylvania to California. I'm gonna use layman's terms here. That's what I do. I'm gonna use layman's terms. You need to take a bus trip from Pennsylvania to California, but you're doing this on a budget though, right? So you sitting down and you saying to yourself, I know I got a bunch of tolls I got to run through to get to California. So I'm going to route my path based on the cheap tolls I'm going to have to take to get there. Okay? Now, that could take you down to Texas and then back up to California. Okay? Which may not be the best path to take. You follow me?
Mhm.
Because in OSPF, that is a possibility. Okay?
Right.
Something like EIGRP, that don't care about no cost. That's looking at the fastest path. So it's looking at Autobahn. It's looking to see if it can find you an Autobahn in the United States,
Mhm.
which you ain't gonna find that. It's looking to see if it can find you an interstate that has a speed limit of 105 miles per hour, which it ain't gonna find that. But just to give you the idea, we're talking about if EIGRP finds a 10 gig link or a 100 gig link, it's gonna go that route.
Mhm.
Follow me?
Yeah.
OSPF might see that 10 gig link, but based on some calculations, it might not take it. That's the thing that's backwards about OSPF.
You just have to customize it, right?
Yeah, that's the thing about that. And yes, you can customize the cost criteria within OSPF itself when you start designing your networks. Like I said, OSPF is a very complicated protocol, and you just scratching the surface. Yeah, go ahead.
Quick question. To modify that, like the cost and that, it will be the reference bandwidth, right?
Right. Auto. Yep.
Okay.
Yep.
All right. Sounds good. I just want to make sure.
Yep. Because once the bandwidth, once the speed gets to a certain point, the cost becomes the same.
Yeah.
And
I saw that.
That's what happens.
Saw that earlier. I was studying OSPF earlier, and I was reading that by default, like Cisco devices, I don't know if the new ones do that, but by default, the reference bandwidth, it will make 100 megabyte links have the cost of one by default.
Yeah.
I don't know if that's on the old devices or the new ones. I don't know if that has changed.
Well, the thing is, it makes it a full integer because it can't do it in decimal format. So it's like, once you get to a certain point, it becomes decimals. All of it's just pushed to one. So 100 meg, gig, 10 gig, it all becomes one.
Okay.
And that's when you got to start getting a little bit more sophisticated with changing your parameters around, changing the settings around.
Good question, Claude. I mean, you have been in the game for a while now. How is it in the real world? You guys in the real world use OSPF too, right?
In the real world,
yeah,
customers and your clients will try their best to keep things defaulted. Okay, because when people start customizing configs, you got to start keeping track of that stuff. And I'm gonna tell you this: you customize some stuff today, right? January 26, 2022. And what happens is January 26, 2026, 27, you're making a phone call to, like David over in TAC, Kelvin, Jermaine, those guys that work Cisco TAC, because something's not acting right. And come to find out, you've made some customizations to your configs. And now what's happening is stuff's not working like it's supposed to. So most clients in their good effort try to keep things defaulted as best as possible.
Okay.
Cool. Guys, any other questions? Ramsey, awesome job, by the way.
Thank you, guys. Each time it's a little easier, you know, and this is all going to really help when I am interviewing next week when I have my CCNA. So thank you all for leading the pack, you know.
More than welcome. More than welcome.
Excellent. Well, guys, on that note, I'll go ahead and end this. Recording will be up shortly. And Ramsey, we'll see you tomorrow night.
I appreciate that. I'll be ready. Thank you.
All right, buddy. Later.